Hey everybody, Mr. Judson here. So one of the things we want to take a look at today is, yesterday we talked about radian measures as a new way to measure angles. And we've got kind of the old way degrees. What if I want to convert those back and forth? Kind of like, okay, here's a measurement in the metric system. I want to convert it to the standard system so I understand. Or it's in the standard system and your science classes don't use standard, they use metric. How do I convert to that? So same thing with radians and degrees, all right? So what we want to look at is, first of all, the idea of our unit circle. And I'm going to pick this angle right here. We said that that angle would equal either 180 degrees or pi radians. Which really means those are both the same, right? So if I have a fraction like this, pi over 180 degrees, I'm going to claim that that equals 1. Which most people would look at me and go, Judson, that's the dumbest thing I've ever heard. 3.14 divided by 180, there's no way that equals 1. But we don't want to think of it that way. We want to think of it as half a circle divided by half a circle, right? That equals 1. Top and bottom are the same. It's just like when we convert units and we say 1 foot is the same as 12 inches. Well, there's no way that 1 divided by 12 equals 1, but 1 foot and 12 inches are the same, and so those do equal 1. All right, same thing here. And likewise, if I flip this fraction over, 180 degrees over pi, that's also going to equal 1. And so what we want to do is when we convert one measurement to the other, I want to multiply by one of these two fractions. Okay? And when I'm trying to choose which fraction I'm going to multiply by, what it really depends on is, do I want the degree symbol to cancel, so I'm getting an answer in radians, or do I want the radians to cancel, so I'm getting an answer in degrees? What am I trying to convert to? Okay, whatever I want to convert to, I want that to be in the numerator. All right, let's do an example. Let's say that I want to convert 2 pi over 5. Okay, there's no degree sign there, so it's in radians. I want to convert this to degrees. Okay, so to do that I would say 2 pi over 5. Let's see, I want the degree symbol to show up, so I'm going to put that in the numerator. And I'll put the radian measure in the denominator. So if I'm multiplying by a fraction that equals 1, I'm not really changing the value here, I'm just changing the way that it looks, right? So whatever I get for an answer, it's going to be equivalent to this. So let's see, the pi's will cancel. When I multiply this, I'm going to get 360 over 5. Alright, so I'll pull up my calculator and I'll go ahead and divide that. I've got 360 divided by 5. And there's what we get, 72 degrees. Okay, now notice how the pi's canceled, and so the label that goes with that is radians. So the radians canceled as well. There's a degree sign left over, so I should have had that right there. And that equals 72 degrees. So I have now converted 2 pi over 5 into degrees. Let me give you guys one to try. Alright, so let's try this one. We're going to convert 3 pi over 8 into degrees. Okay, you guys give it a shot. Alright, so 3 pi over 8. I want to convert that to degrees, so I want 180 over pi. There's my degree sign. So again, the pi's will cancel. And I don't want us to think that there's always going to be a pi that cancels. What if I just wrote this down as 2.5 radians convert to degrees? What would that look like? All right, so let's see, 3 times 180, that's going to be 540, is that right? Let's check it out. 180 times 3, yeah, 540. And then I want to go ahead and divide that. So 540 divided by 8, and there we go, 67.5 degrees. So if I had a problem where it was just some decimal number, you know, let's say they're asking us to convert 3.7 to degrees. And I know that's radians because there's nothing written there, there's no label to it, right? There's no degree sign up here. So I'd have to do the exact same thing. I would think 3.7, and this is why sometimes I like to write the word radians in there, times 180 degrees over pi radians. It's the units that you want to cancel. Okay? It's nice when pi cancels, but it doesn't have to happen. The units is what I really want to have cancel. So I'm going to do 3.7 times 180 and then divide that by pi. So 3.7 times 180 divided by pi. And there's what I get, 211.994 degrees. Did I get that right? Yeah. Let's try one where we're going the other direction. I've got a measurement in degrees, and I want to convert that back to radians. So, convert 200 degrees to radians. You guys go ahead and give it a shot. All right, so all I have to do is I just have to make sure that the degree symbol cancels. That means I need to flip this fraction over so that degree symbol is in the denominator. So 200 degrees times pi over 180. Remember, we'll just think of this as a fraction over 1. And the degrees cancel, so that's how I now know that I'm in radian mode. And so what I have is 200 pi divided by 180. So I know that I can divide top and bottom by 10, and then I can divide top and bottom by 2 and get 10 pi over 9. So that's not an angle that I could easily find on my unit circle, right? If you look back at that unit circle, all the denominators were like 2, 3, 4, and 6, or 12. That just means this is a different angle, and it's somewhere between two of those tick marks somewhere. I don't know where. Okay? If I wanted to figure out where this was, I would just do 10 pi divided by 9. Okay, it's about 3.5 radians. So this is about equal to 3.5 radians. So where would that happen? There's my circle. I know that 3.14 radians is right about here. So remember, if we have the tick marks in here, there's always 5. Each tick mark is about 0.25. So if I add 0.5 to 3, it's probably going to be a little bit less than this second tick mark right here. Here's my initial side, there's my terminal side. So what's that as an angle? Well, it's a little bit more than 180 degrees. Okay, that's the way I would think about it. All right, so another thing that we need to talk about is this thing called DMS, or degrees, minutes, and seconds. What that is it's a way to take a degree and break it up into smaller pieces. Now, when we're just drawing angles on a piece of paper, that's probably not a big deal. But when you start talking latitude and longitude, Let's say you're out in the middle of the ocean and your boat's sinking and you need help now. If you just send off a message that says, I'm at 24 degrees latitude, 13 degrees longitude. I don't even know where that's at. Okay? But you just gave them an area that's probably like, I don't know, 600, 900 square miles, something like that. It's a big area to have to search. And with ocean currents and stuff, what happens is helicopters or airplanes, they'll fly down, they'll turn on the come back, and then turn fly, and they'll just go back and forth looking for those people. But if you can give them your location in degrees, minutes, and seconds, break it down into smaller units, you can get an area about the size of a classroom where the helicopter will come right to you and lower down and they'll help you immediately. I just saw a YouTube video with a big ocean liner that broke in half on a big wave. That's not what you want to have happen when you're out there in the ocean, driving a boat. You don't want your boat breaking in half. So they had to call for help right away, and fortunately somebody was able to come and help them out. So that's why we need to do this. So what we want to realize is that in 1 degree, there are 60 minutes. It's just like a clock. Okay? 1 degree is equal to 60 minutes. And 1 minute is equal to 60 seconds. Okay? Kind of makes sense. Why make it different than a clock? Let's just leave it the way we learn how to tell time. But what we can do is we can take an angle measure, maybe it's in decimal form, and put that into degrees, minutes, and seconds. Our abbreviation for minutes looks like this. So let's say we have 5 minutes, and our abbreviation for degrees, let's say 23 seconds. There's 2 tick marks. And of course, this is just a degree symbol. Okay? So we can talk about someone's location, or we can talk about an angle. That's my abbreviation for the word angle. It looks like the initial side and the terminal side. Okay? So an angle can equal something like 32 degrees, 14 minutes, 32 seconds. It gives us a little more precision when we're talking about things. So one of the things they're going to ask us to do is to convert 27.32 degrees into degrees, minutes, and seconds. So how would I do that? Well, I know I have 27 degrees, so I'm going to write that down like this. And then what I have is 0.32 of a degree. Right? A decimal just means part of something. So I've got 0.32 of 1 degree. Well, 1 degree is the same as 60 minutes, right? So what I really have is 0.32 of 60 minutes. It's like a percentage. 32% of those 60 minutes. So what I'll do is I'll take my calculator and I'll just say, okay, I've got 0.32. So 0.32 times, that word of means multiply. When you do a percentage of something or a decimal value of something, you multiply. Times 60. And so I've got 19.2 minutes. Okay, but I want to convert it to degrees, minutes, and seconds. So now what I need is I've got 27 degrees, 19 minutes, and I've got 0.2, or 20% of 1 minute. I've got part of a minute here, right? So I want to take 20% of this. So I'll just do 0.2 times 60. I should be able to do that in my head, 12, right? 60 times 0.2, yeah, 12. And so I got exactly 12 seconds. Now, if that ended up being something like 12.7, well, I just round it up to 13 seconds. Or if it's 12.1, I'll just round it down to 12. Okay? But there it is. I've converted this angle measure into degrees, minutes, and seconds. Let me give you guys one to try. I guess this would be number 2. I want you to convert 3 pi over 7 into degrees, minutes, and seconds. You guys are like, what? Come on, Judson. Well, I have to convert this to degrees first. We just did that, right? And once I get that into degrees, well, then I'll convert it into degrees, minutes, and seconds. All right, you guys go ahead and try it. All right, so I've got 3 pi over 7. I'm converting into degrees, so I want to have 180 degrees divided by pi. I need that degree symbol. These pi's will cancel, so I'll just do 3 times 180 divided by 7. So my calculator, I've got 3 times 180, I feel like I did this before, divided by 7. 77.143 degrees. Now, I'm going to keep track of that exact decimal in the calculator. But here I'm just going to write down 143. All right, so now I want to convert that to degrees, minutes, and seconds. So I know I've got 73 degrees. And then I've got part of a degree here. So I'm going to take that decimal number times 60. Right? I've got part of those 60 minutes. So when I go back to my calculator, I don't want to lose all these digits here. I want to try and keep this as exact as I can. So I'm just going to say minus 77. I'm just subtracting the whole number part. Now I've got my decimal value. And I want to multiply that times 60. And so there's what I get, 8.571 minutes. But now I need to take that 0.571 and convert that into seconds. So I'm going to have 73 degrees, 8 minutes, and part of 1 minute. 1 minute equals 60 seconds, so I really want part of those 60 seconds. So I'm going to go back to my calculator. I don't want to lose the decimal value, so I'm just going to subtract off the whole number part, so minus 8. And now I want that number times the 60 seconds. And I got 34.2, so I'm just going to round that to 34. And so what we would say here is I've converted this to degrees, and then I've converted it to degrees, minutes, and seconds, and I've rounded it off to the nearest second. All right? All right, so that's 2 things we have to do for today. Converting radians and degrees back and forth, and then also writing down answers in degrees, minutes, and seconds. All right, so the third thing we need to do for today is we want to be able to calculate arc length. And what arc length means is if I'm walking around the arc of a circle, how far did I walk? Okay, how far is that distance? Well, when I look at this, I just think of this as it's part of one complete circle. It's a portion of the way around. How far around is it? Well, let's see. If I put an angle right here, start in the initial side, and the angle goes to right here, and we'll just call this theta. So if you guys don't know this already, in trigonometry, a lot of times they use Greek letters to represent angles. It's like a variable. But instead of using x or y, they like to use Greek letters. So theta is the most common one that's used. All right? That's an h, theta. It's just a circle with a line through it. Alpha gets used a lot. It looks like a fish. Beta gets used a lot. It looks like that. It's just like a B, except the side goes down farther. Those are all real common. So anytime you get a weird variable that shows up in the angle, don't worry about it. It's just a variable. It's a Greek letter instead of our normal alphabet. Okay? All right. So whatever that angle is, I know that a full circle is 360 degrees. And so if I want to know how far I walked partway around that circle. I did a fraction of, or a percentage of. That word of, again, means multiply. The fraction, or percent, is whatever that angle is out of 360. So my arc length, I'm going to abbreviate this AL, my arc length is going to equal a fraction of the distance around. So there's my fraction. The word of means multiply. And how do you find the distance around a circle? Circumference, right? 2 pi times the radius. So times the circumference, which ends up equaling theta over 360 times 2 pi times the radius. That's how we're going to find arc length. If we're in degrees, okay, what if our angle is measured in radians? Well, a full circle in radians is 2 pi, so we'd have theta divided by 2 pi. So arc length would equal theta over 2 pi times 2 pi times the radius if we're in radians. Alright, so let's try a practice problem here. I have no idea what number I'm on. Alright, so let's see if we can do one of these. We want to find the length of an arc with a central angle of 115 degrees and a radius of 24 inches. Okay, all we got to do is plug it into the formula. You guys go ahead and try it. Alright, so I don't really need a picture, but if I did make one, it would look something like this. I've got this arc that starts right here, and it goes around the circle. There's 90 degrees, so 115 is a little bit past that. So there's my initial side, here's my terminal side, and I've got a 115 degree angle. And the question that we're trying to answer is, what is this arc length? Okay. Well, I've got 115 out of 360 degrees. So that's my fraction of the distance around a circle. Times, my radius is 24 inches. So I'm going to do 2 pi times the radius. And so let's see. I could just multiply straight across there and then divide by 360. That's probably going to be the easiest way to do this. So I've got 115 times 48 pi, and then divide by 360. And there it is, 48.171. So this is arc length equals, and I got 48.171 inches. So these are not meant to be long problems, okay? All right, so the last thing that we need to look at, is kind of similar to what we just did, but it's called the area of a sector. So, area of a sector. And so what we're saying is, if I've got a circle, and let's say there's a piece of pie, what's that area right there going to be? Well, I think it's kind of the same as what we just did. I've got some angle theta right here. And what I've done is I've kind of taken a certain amount of the circle, a fraction of it, okay? So my fraction is going to be that angle out of 360 degrees, right? So as I start to form an angle here, what fraction of the circle do I have? I've got a certain number of degrees out of 360 times area of a circle, pi r squared. There it is, that's my formula. If we're in degrees, and the formula would be theta out of 2 pi, because if that's in radian measure, a full circle's 2 pi. So I've got a fraction of pi r squared. And my pi's would cancel, and then I would just go from there. So this is if we're in radians. So let's try a practice problem for this. Alright, so what I have here, here's my initial side, here's my terminal side, and we're trying to find the area of this region right here. So my angle measure is 5 pi over 4, the radius is 10 centimeters, and we want to use that information to figure out the area of the shaded region. Alright, you guys go ahead and try that. So again, these problems aren't very difficult, it's just a matter of plugging the numbers in. So I've got 5 pi out of 4 of 2 pi, so there's my fraction, theta divided by 2 pi, times pi r squared. So pi times 10 squared. That's going to be the area of this region right here. So let's see, if I think of this as 2 pi over 1, I got to flip that over and multiply. So that's going to give me 5 pi over, when I flip it I get 8 pi times 100 pi. These 2 pi's will cancel. And so what I'm going to get is 500 pi over 8. And I just got to put that in the calculator and see what I get. If I was going to do an exact answer, I would divide both of these by 4 and get 125 over 2, or 125 pi over 2. That would be an exact answer. But I'm fine with decimal answers. 500 pi divided by 8. There it is, 196.350. So I just realized something that I forgot on the previous problem. I don't think I labeled my answer. Oh, I did. Okay, never mind. Inches. Yeah. So because I'm talking about area here, we got to think, well, how is area measured? Area is measured in square units, right? So this answer is going to be square centimeters. So square centimeters. All right, there it is, you guys. That's what we have for today. We want to be able to convert radians and degrees back and forth. We got this new idea of DMS, degrees, minutes, and seconds. We're breaking degrees down into smaller units. And then we've got area of a sector and also arc length. All right, let me get you guys an assignment. All right, so assignment number 1, continued. This is our Wednesday piece. And there won't be a Friday piece. That's a day off for you guys, so we only have 2 days worth of work this week. We're going to be on page 191 to 192. We're going to do 55 to 77 odd. Only part A. There's a part A and a part B for several of these. We're only doing part A, okay? And then 87 to 93 odd. All right, there it is, you guys. That's it. I will see you guys on Tuesday. All right, take care. Stay safe. Bye.